So if you want to clone this repo now, you use git clone, then paste this URL. And this URL should be the fork of the main repository. So you can be able to create the PR requests after you are done with your exercises. So it will be merged into the main branch. So I've cloned it like this. So after cloning, you now cd into it. Intro to TypeScript. Like this. So you can now open it to your VS Code or open it to your VS Code. Then run the npm install command. You can use the shortcut code to open it to your VS Code. And when you open it, you'll see these files, the index.js file, with all the JavaScript code here. And you also see index.ts file, where you can add your own solutions to this. So basically, you are just changing this JavaScript code into TypeScript by adding types to it. That's just the basic goal of this whole exercise. Then when you are done, make sure you check out to a new branch. If you want to check out to a new branch here, you use git checkout -b. Let's say I'm using fit ts class activity. Can you see now? It's no longer on the main branch. It's now on my branch, fit ts. So it is this your branch that you will push your solutions to, then to be merged into the main branch. Do you understand now? I need your reactions if you understand the exercise. Yeah. Okay. Okay, thank you very much. So, yes, let's hear you, Ben Zumaki.
Yeah, good evening, Mom.
Good evening.
Yeah, I want to ask for the video of the last class. It's not on Gida's YouTube channel.
It's on the YouTube channel. Okay, I'll share it after the class.
All right, thank you very much.
Thank you. All right, so moving on.
Sorry, please. What you just explained with the GitHub you shared, please, can you just come again with that?
Can I do what?
What you just shared with the GitHub you just shared, like, please, can you just come again with that?
Like I said,
what do you want us to do with the GitHub you just shared?
You need to change the TypeScript code, the JavaScript code to TypeScript. The repo just looks like this. Can you see my screen? This is what is on the repo. You have TypeScript, JavaScript code on strings, numbers, Boolean, union type, arrays, and intersection type. So what you need to do is change this JavaScript code into a TypeScript code. Do you understand now?
Yeah, I understand. But the last class, anyways, I'll check the YouTube. The last class, when you left, the network was hanging for a while. Before I could join back, the class had ended. So how do we now change it back to a JavaScript code to a
Yes,
TypeScript? Can you
I
run us through
joined
that?
back, so you can check the recording. Though I'm going to do a quick recap on the intersection type now, so we can move on to the next. Okay.
Yes, please. We need more explanation on that intersection and union. Even while doing the assignment, I found the union parts quite challenging.
Okay. All right. So now I'm giving this to me. You can all see my screen, right? Let me increase this again. Is this okay? Okay. All right. So I'm only going to do a solution for the intersection type and probably the union type. So I'll start with the union type. Okay. So let me take this function to university as well. Okay. So like I said in the last class, if you want to, we have a function and we want it to accept both a number and a string. Normally, TypeScript is inferring this as an anytype, which I'm going to explain in this class what an anytype is. So our function is not supposed to return an anytype for any reason because that causes a lot of bugs. Yeah. So that TypeScript does not know exactly what we want to return or what we're collecting with this function. So it's giving an error. We cannot collect a number and also collect a string in this function because TypeScript does not know exactly what. So now we have to explicitly state what data type the function should collect. Now for us to do that, we're writing a function and we're calling it print ID. Okay. Now we want to collect a number and a string. So we're going to use our colon. All right, string or a number. So we're either collecting a number or a string, but not both. It is only in the intersection type that you can collect both a number and a string at the same time. But in a union type, you have to collect only one, either the string or the number. So we're going to console log user ID is. Wait. Let me comment this out. All right, so now let's call the function. We're going to print ID. Now, if we impute a number here, our function does not return an error. But let's say we impute a Boolean type. You can see the function is giving an error. Why? Because it is neither a string nor is it a number. So you can now put a string here. So this is how you can use your union type to like limit the kind of data type that comes into your function. Okay. That's for the union type. Now let's do one for, or do we understand this? Do you understand this, the union type? Do you have any questions for the union type? Yes. Somebody reacted a sad emoji. Yes, can I hear you, Emmanuel?
Okay, please kindly do a short recap on that because I'm lost. Sorry.
Are you just joining? Okay. Okay, so I'm going to now in your plain JavaScript code, running this code is not going to give you an error. Let's try running the code for this JavaScript code. Okay. Now you can see that we got JavaScript did not restrict us from not imputing the different kind of data type. I can even come here now and print true. This should cause a type error in TypeScript, but in JavaScript, it doesn't. Can you see? We are getting the output. But if you come to your TypeScript now and do this, it will not run. New error. You're getting this error. Why? Because TypeScript sees this function as an any type. It's returning an any type, meaning the compiler does not know which type we are returning with this particular function. Why? Because we did not explicitly state the type that the function is going to return. Okay, so you have to like explicitly state, especially for functions, like it's very important for functions that we state the type that is going to return in order to reduce any kind of bugs you can get in our code. So we don't have to like start doing unit tests to actually check, okay, is this actually a string? Is this actually a number? Because we need this particular type of data. So for us to correct this code, we can add a string here. So it will be either a string or a number. So this is how we can now use our union data type, because we have the data type string and number. So in order for this function to either collect a string or a number, we're going to use the union data type, or this straight line in the middle represents or. Okay. So now our function can be able to collect either a string or a number, nothing else. So if you run this code now, you see that it runs perfectly. Okay. And let's say we try to print a boolean. You should get an error, right? And it stops every other thing in your code from running, because the compiler is throwing an error to that particular line of code. So even from your development environment, you can be able to catch this kind of little errors that can cause bugs in production environments. So do you understand the union type now? Reactions, please, if you understand. All right. Okay, so another thing I'm going to explain is the intercept. Who is Lucky? You are giving a bad thumbs up. Can I hear you?
Yeah, I can't understand what you're saying just now.
Hmm?
I don't get what you're just explaining right now. I don't get.
Are you just joining the class? Did you join the first class?
Yeah, why not? The first class was kind of cracking and stuff, so I wasn't that active that much.
Okay. So, but do you know what a string is and what the number is?
Yeah.
Okay. So in TypeScript, if you do not specify the exact type you are trying to return in the function, it's going to give an any type. Like it will implicitly give that function an any type. And an any type can take any type of data. Okay. And our function is supposed to return a particular data type. So it's going to give you an error in TypeScript. Right. So now, in order for us to be able to collect both a number and a string in this function, we have to explicitly state that we want a string and a number. And for us to do that, or a number, sorry, and for us to do that, we have to use the union type that can help us combine two data types, two different data types together in one particular function. So that's how we're using this command here, the or. They call it logical or. Yeah, it's
Okay,
called
sorry,
the
please. I have a
union.
question.
Yeah, I'm
Okay,
listening.
thank you. I don't understand. Okay.
Okay.
My question is, this function that was written at the top, like, is it necessary? Like, when you just say this console.log, sorry, when we just print this print ID and we wrote all this, because it's not as if it's actually performing any specific function. Like, is there no way for us to just say, just print so? Like, is that function written at the top, is it performing any particular task? Because I observed, like, it's not as if we did any arithmetic or anything. All we did is just print out those words.
Yes, it was like, it's a basic example. I'm trying to explain how we use the union type. Okay, so it's like a basic example of how you use your union type. Do you understand now?
Yes, I do know.
Okay. So that is like a basic exercise. You know, the first class was introduction. Okay. Now for the intersection type, so this type, we want to use this type now to combine this particular object and this object into one object. Now, in order for us to do that, we can use our intersection type. For the union type, you can either collect one data type or another data type. But for intersection, you can collect both. So this uses the logical AND operator. Okay. So now, firstly, we have to change the objects. The first object to a TypeScript code. Okay. So there are several ways we can implement this. Yeah, but I'm going to use like the simplest version for now. So we can implement the first object as okay. So say let's username. It should return. Okay. It should contain name as a string. Yeah. Email as a string. Okay. We're going to collect Emmanuel and email Emmanuel at example. This is duplicated, so I'm going to comment this out. Comment this. So now I just implemented a simple version of this. So if you want to change this object into a TypeScript code, we have to implement that let user be equal to this. The name should be a string and our email should be a string. Let's say we want to add phone number to this object. We can come here now and add phone, then make this number. So we'll now come here and include it here. You get. So now this will now serve as, okay, this is a parameter coming into this object. Now, if you have another object account, same thing, same syntax. You have your account number. You can try to put it to a new line. String, balance is string. You can also add your email, but I'm not going to add that. Yes. Okay. Now, this also implements the first one. So this should be equal to your account number and your balance. Yeah. So now this particular method implements these objects directly. The one that Mohammed used is a type alias. I'm going to explain that too. So this one is going to implement the object directly the way it did in the JavaScript. Okay. Now let's try combining them into one object. So to combine them into one object, we're going to say let customer.
Sorry, please. Let me just come in, please. Is there any
Yeah.
difference between these four?
Between what? Sorry, I can't hear you. Who was speaking?
Is Ahmed Rabi? I think he's out.
When it comes back. So to combine this, we have to combine all their parameters first. So we're going to take the parameters of both these two objects and put them here. So I'm going to just add them and just use this here. So this spread operator also prints. It will bring out all these the objects in it, the members of the objects into this particular one. So now we can now console.log customer. So this particular method does not actually use too much of TypeScript features, right? We just added like the types, but it's still the same JavaScript way of writing this particular object. Okay.
Sorry, ma, can you help us unwrap your comments?
I should do what?
Wrap your code. It's a long code. Going to the long other side. Wrap it to make it short.
Oh, okay. This is good. All right.
Yeah,
So,
thank you.
okay. So it's basically the same implementation with this JavaScript. Okay. But if we were to use more advanced TypeScript features, we would have used the type alias that Mohammed used. Okay. Now let's try printing this to see if we are going to get the output. Okay. So now we can see that our customer is giving us the name, email, phone, account number, and balance. So this spread operator is actually spreading the members of our user type and the object type. This is how you can do it with just simply adding the types like we did for the union type. Okay. So now I'm going to explain a type alias. Let's start with the any type first. Let me share my screen.
Sorry, please. Before you go further, please can you just go back to the place you just Is there any difference between this declaration you did for this user, account, customer, please? Is there any difference between the three?
Between
these three, what you just did for this user, account, customer?
This user is an object on its own, and its members are just name, email, and phone. Okay. Now the name is a string, email is a string, and phone is a number. The account has different members also, account number and balance. Do you understand to that point?
I understand that.
Okay. Now this customer object is adding both the user object and the account object into one object. So for here, we're using the spread operator, okay, to implement this. Do you understand this point?
Yes, I understand that also.
Okay. So now I want to explain the any type and type alias. So we can now implement this intersection type in a more advanced TypeScript way. Okay. Did we get that now?
Yes, I understand you now. Thank you.
Okay. So I'm going to share my slide. All right. So, recap of last session. I'm going to go through it. We did basic data types like string, number, booleans. Then we did the compound types, union, array, and intersection. We also talked about the definition and importance of TypeScript, and we all set up our TypeScript environment. We also talked about type inference, right? All right, so for today, we're going to go more into advanced data types, types functions, that's using parameters and return types, using interfaces for structure, creating classes and constructors, understanding access modifiers, public, private, and protected. Okay. So firstly, we're going to start with the any type. So the any type disables type checking. It can store any value and turn off TypeScript safety. So you are advised to use this only when you don't know the type. It is risky to use when you use it because TypeScript help you. They're like TypeScript help you to detect errors. Just like when we were doing the function for the union type, we noticed that the TypeScript compiler was seeing that function as an any type. Why? Because we did not state the type that that function is supposed to collect. Okay. Let's try let's go into the docs, TypeScript docs, to look at this any type. Right? Okay. So this is any type here in the TypeScript doc. TypeScript also has a special type any that you can use whenever you don't want a particular value to cause type checking errors. So TypeScript any type actually just bypasses the main reason why TypeScript is TypeScript. Because TypeScript is TypeScript because why? It helps you to like do type checking on your code. So you don't have unnecessary errors like maybe when you're supposed to get a number, you're getting a string. Now the any type it bypasses those type checks. So it's just like once you pass it in, anything can go into that particular variable or function you pass an any type to. Okay. And you are advised to actually not use the any type. Right. Okay. Yeah, here it is. So now I'm going to explain a type alias. Now, type aliases helps us to like, it gives a syntax for your data. If you want to put your data into a particular function, it gives you syntax. Let's say you want to collect either a number or a string, or you want to collect a number and a string. You use your type function to like collect like a structure for your data. This is mostly used with our other type, our other combination types, like your union and intersection type. And it also helps us to not repeat ourselves. You know the dry principle, do not repeat yourself while like coding. Okay. So this is the syntax for your type. You get a type, then you name it with your Pascal case, start with your capital letter. Then you have your parameters in it. So if you now call a function and give your parameter this, it should call in this type. Give it this type. So it has this particular one parameter now have two parameters in it. You can see one parameter now has two parameters in it. So inside of this function, you can now call the two parameters of this type. So this is just the basic syntax on how to use your type alias, right? Okay. So now we're going to use this syntax to implement our intersection type. Now, let me go back to my screen so that we can understand it more. Why am I getting so many sad reactions? What's happening? Mike, can you share your problem? That's okay. So I'm going to explain the type alias while I'm implementing it with the intersection type. Okay. So don't worry, we understand it more. And we're going to use it like a lot here. So okay. Can we see this screen? I need some reactions if you can see my screen so that I can. Okay. Thank you very much. So now we're going to implement this, our intersection type with the type alias. Okay. So let's all calm down. We'll calm down. So now if you notice, our user type has this parameter. What is that, please? Okay. Our user type has these parameters: your name, email, and phone number, which I added, right? So now, if you want to create a type alias for this particular object, we're going to create it is like a template. Okay. So we'll do type user is equal to. Now we'll now come here. You know, this stuff we passed into this place, we'll have to pass it into our type alias. This name string, email string, phone number string. So we don't repeat ourselves, having to write these parameters here and coming here also to start writing it here. So we'll just implement those in our type. So now we're going to write this, the name string, comma, then email string, comma, then your phone, we have phone number, right? Okay. So now this is the type alias for our user. Now let's create a type alias for the account. Notice is the same syntax, the one on the top. So account number should be a string. Balance. Okay. Right. So now you see that the arguments we passed into here, our parameters, are what will now be in our type functions. So how do we now implement our actual objects from these type functions? I'll start with the user type. Okay. So let's your user. So now this user, instead of it to now start collecting all this one by one, it will just implement this whole user that has all these parameters already. So it's like storing your parameters in a particular variable. That's what your type does for you. It helps you to like keep a particular structure for your data. So you don't have to start typing it one by one when you're implementing that particular object. So we'll just use this user which has all the parameters we need. Okay, now if you hover over user, you can see it has the name, your email, and phone. Why? Because it is using this type function that helps us to like just gather our data together. So it's like a structure for our data we can use when implementing objects like this. So now you can now come here and say his name is Emmanuel, his email is emma@example.com. Yeah. Then his phone number is this. So because this is a duplicate, see, we declared blocks. So I'm going to comment this. Okay. So please, you understand this part? Please, oh, what's funny? What's happening?
Please take it one more time, please.
Listen, no. Okay.
If I can't see the screen, I can't see anything again.
Can you try rejoining the class? Log out and try rejoining. Okay. So I'm going to re-explain this, right? Now, formally, we implemented these objects, like objects in JavaScript, but we added the types, like we explicitly stated that, okay, we want a string for the name, a string for the email, and a number for the phone. Okay. So now, instead of us to start typing each and every one of these when we want to implement this particular object, we can store our parameters, this name, email, phone, with this particular, with their types attached to them. We can store them in a type method like this. So we'll store the parameter for user in a type called user, the parameter for account in a type called account. Now, if you look at this, your account here, we can even decide to come here now and add account name. Let's call it Emma, right? We come here and add the parameter as string. Okay. Now, if we want to implement this in this type, we have to add that particular account type, account name as a string here. Okay. So if you want to implement this account type, we'll write let account. Now take this account type as a parameter. Instead of us to type all these one by one as a parameter, we can store them in a type and then call them as one. It's just like using a variable to store, or an array, using an array to store a particular information. So if you need that information, you just call that array name instead of calling everything one by one, because all these things can be more than this. Okay, you can have more information than this for a particular object. So instead of you to start writing each and every one by one when you want to implement that object, you can store them in a type, then call it with just the name of the type. So do we understand to this point before I move on? Do you understand, please? Okay. Those that were saying they did not understand, I want to see that you understand now before I move. Because as we are going, you are going deeper. Okay. So now let's finish the implementation before we move to the cocoa of today. All right. So now we've gotten the type for our accounts, right? Now for us to implement this, we are going to write account number. You can now put the account number of the person you want to put, the balance, and his name. So we're going to comment this part out because it's now looking like it's a duplicated code. Yeah, because it's like the same thing, right? Okay. So now that's the part for the objects, user and account. Now, how do we now do the intersection between user and account with our customer? That's where the tricky part comes in. So now, because we implemented a type for user and account, we can easily use our intersection operator, our intersection type, to merge them together without having to use our spread operator. Okay, because you cannot always use spread operator every time. So now we're going to do a different type for customer. And this should accept user and account. If you notice with the one we did before, this simple implementation, we did not use the and. We did not use the and type. Now, once as we've implemented it as types, we can easily use our and type to collect both parameters at once. If you notice here now, in this customer, we had to start typing all the parameters together to get the parameters for our customers so that they will be together. But here, we don't need to start typing each parameter for each object. We just have to merge them together using our intersection type. Okay? Do we understand to this point? Before I move on. Reaction, please. Okay. Great. So now, let's now implement the customer object itself. So let customer, you now call the type of the customer. So when you call this type now, let's do equal to. When you call this type, if you hover over it now, you can see it is an intersection between user and account. So that means the parameter for your user and the parameter for your account are all together in your customer type. So you don't have to start typing each. Just imagine you have like 10 parameters for your user, 10 parameters for your accounts. All their metadata are both 10. You will now start typing each and every one for the customer. It's like a long stuff. So once you already have it in your type, you can easily use it anytime you want, in any function, in anything you want to use it for. You just call that type, and you know that, okay, this is the parameter that is going into this particular variable or this particular object. Okay, now we can now call the name to be, because it is stored, our name is stored in user, we're going to use user.name. And then if you want to call your email, where's our email stored? Our email is stored in our user type. So we're going to call email user2, user.email. So our phone is also stored in user.phone. Okay. Then our account number. Our account number now is stored in accounts. So we're going to use account.account number. Okay. Then balance is also account and the same. And it's spelled this. Okay. So now this is also looking like it's a duplicate. So I'm going to comment this out, right? Okay. So now we can now console.log our customer. Okay. So now you can see I don't need to start typing each one because it's already implemented now in this object. All I just need to do is call it as user.name, user.email, user.phone. Why? Because it's already passed in as a parameter to my customer type, which I am calling into this object. So now if we run this code, we should see, right, now you can see, okay, it's still running. Let me clear this and run it again. So yes. Okay. Okay. So we can see this now. We have our name, email, phone, account number, balance, account name. It might not look like much now, but if you are building for a larger scale project, okay, this will actually save you a lot of stress, a lot of repetition, a lot of having to repeat yourself every time. Because once you've implemented it into a type like a type alias like this, you just need to call that type into whatever object you want to implement it for. Okay. So in order not to mix it up, because we have another type that is similar to this. Okay. So the type alias, you can only use it in your objects for your union types, your intersection types. Okay. We also have our interface. The interface is mostly used for classes and is like much more deeper and for a much more broader topic. So I want to confirm if everybody understands this type alias now. If you understand it, please, I need your reaction, please. Okay. All right. So let me go back to my slide so that we can move on. Thank you so much, everybody. Okay. So we also have the tuple type. The tuple type are fixed length arrays. Okay. You just need to know that they are fixed lengths. They don't have like once you define a tuple as this tuple is only receiving 3 parameters, or this tuple is only receiving 3 members. After these 3 members, we're not accepting any other member. That's it for a tuple. It has to be, it is fixed. That is just is life. It just has to be fixed. So if you define a tuple as two elements in a tuple, that's how it's going to be for the rest of your code. You cannot change it, you cannot add, you cannot push. You know, in an array, you can push, you can remove from an array, you can extend your array. But for a tuple, as you defined it as 3, as you defined it as 4, as you defined it as 2, that's how it's going to be. It's just fixed length. Okay, it's very.
What is the highest?
Yeah.
What is the highest you can put?
You can put any number, but you cannot change it after defining.
Okay.
Like, as you're going further in your code, you cannot go back to your tuple and say, okay, I want to push something into it. You can't do that. All right. So now let me give an illustration using the tuple and like explain. Let me share my whole screen. All right. So let me comment this code out. Okay. So now we're going to implement a tuple. So it's like the same way you can implement an array, but now we're going to give it a fixed length, a fixed number of parameters it can take. So let my tuple have in this space. Let it have a string, a number, and a boolean. Right? I don't want to use this. So I'm going to use a name.
Sorry.
Yes.
I observe like this what's the name? Bringing solutions. I don't understand. Like, will it be doing that for everyone or what? Like before you even type it, most times
No, it's the IntelliSense. So it's already Sorry, can you mute your mic? It's the IntelliSense. It already detects what I want to do, even from my comments. Okay. You notice if I comment a union type now, it's already give me an example. Can you see? So just to close your eyes. so that it's tempting sometimes, but it can give you wrong coding. So let's move on. Now in our tuple, I have a string first, then a number, then a boolean. All right, let me use false. Okay. So you can easily console.log your tuple. My tuple. Now let me use an illustration for an array. So I'm going to define an array now. This one. I'm using the same format with my tuple, right? Can you see? My intelligence is already even telling me this is an array, not a tuple. Okay. Let me use true. Okay. So this is an array and this is a tuple. So now let's see if I can put this my tuple in my array. So mixed equal to my tuple. Now let's console.log mixed. No. Oh, and this is selling sense is really disturbing me. So console.log mixed. Now let's run this. Let me claim it. Okay. So you can see now. Let me even console.log this before adding my tokens. So see, when we console.log the tuple, it gave us this IMA 25 false. Where is this user ID coming from?
Sorry, please. I'm a little bit confused, please. This
Calm down,
tuple and this
calm down. Let me explain. Okay, that's what I want to do now. I said the tuple is a fixed number, is a fixed length array. That means once you've defined it now as 3. I defined it now that it can only accept 3 parameters. That is a string, a number, and a boolean. Okay, and now inside of this tuple, we have a string, a number, and a boolean. If I come here now and add another number, it's giving me an error. Can you see? Type string number false number is not assignable to type string number boolean. Source has 4 elements, but target allows only 3. Can you see? Telling you that this is a tuple and it can only accept this fixed length of members that I gave it to it while defining it. Do you understand that part? Now differentiating it from an array, okay? This mix down here is an array because I did not give it a particular number it should collect. And normally in your array, in your normal vanilla JavaScript, you can push to your array, you can pop from an array, okay? Like you can add to an array, you can remove from an array. But a tuple, you cannot add more things to your tuple because it's already fixed length. It has to be that length that you've already defined it with, okay? Now, the first console.log was this, our tuple, and it gave us this, Emma 25 false. Now, this is our array. It gave us this, John 1 true. Okay. Now, putting our tuple into our array now brought out only the tuple because we just like put it in. It's override this the one we used to define it first. Now, let's try putting our tuple, our array into the tuple. You can see it's giving an error. Type string number boolean is not assignable to type this. Can you see it's giving that array sign in front of it? This is our array sign. So target requires 3 elements, but source may have fewer, meaning we can remove from our array, we can add to our array, but we cannot do that to the tuple. So this is a very perfect example to explain the difference between your tuple and your array. Because they said it's a fixed length array. It's actually, your tuple is actually an array, but it's fixed length. You cannot put more than what's there. Let's try adding another number here now. If you add a number here, we can now add a number here. So you see, the compiler is not shouting, it's not making noise. Why? Because if you try running this again, oh, there's an error here. Let's comment that first. Here, run. Which other errors? Okay. So we can see now the tuple now brings Emma 25 false 30. So this is just a perfect example for the implementation of a tuple. Okay. So do we understand this now? Do you understand the tuple? All right. So moving on to the next. All right. Let me share this one. My slide.
Please, I'm not sure if I understand everything.
Huh?
It's like you are fast.
It's like you are fast. You are fast.
I'm fast.
Yes,
Okay.
yes, yes.
Fast.
Please, let me just ask 1 or 2 questions, please, on that before you move on, please. I just
All
have
right,
like
no
just
problem.
2 things.
All right, no problem. What is this? Yeah, I'm listening. Listening.
No, you go back to the slide now. Let me so I can be seen.
The slide of the VS Code, which one? The slide of
No,
the VS
the
Code.
coding, sorry, no. The coding.
All right. Okay. All right. Okay.
Okay, the first is you mentioned array and you mentioned this tuple. So this my tuple that you wrote after this let. I'm assuming is the variable name, right?
Yes. Yes.
So that means the system is not aware of it. You decide to just name it my tuple like by you, right?
Yes, you can decide to name your tuple any other
Yes,
thing.
you can decide to name your tuple any other thing.
Okay, so that means what differentiates this tuple to array is this string, number, boolean, and numbers that you wrote. That's what differentiates it from the array.
Yes.
Exactly.
That's the only
Okay,
thing.
that's
It's
the
actually
first.
an
Now my
array.
second
That's the
question.
only thing.
It's actually an array itself.
Exactly. So just because you wrote this string, number, boolean number, that's what differentiates it. Now my second question is this:
Yes.
mix is equals to my tuple.
Yes.
Like what's it for?
We can't hear you.
Sorry, am I still in the class? Okay. Why is everywhere silent? I better please say something now.
It seems the network that has issue.
All right, thank you. Everywhere was so silent.
It's like our network is getting issue.
Back. So sorry, guys. My network just wants to mess me up this night. So I'm going to share my screen again. Sorry. Please, who was asking a question? Can we hear me? Good evening.
I can hear you, ma'am.
Yes, somebody was asking a question. Please, can you recap your second question? Is this still on this call, or should I just continue?
Okay, maybe let me see this. Let me see the slide so I can ask. I'm the one. I said the slide, the coding, please.
Can you see it?
Can you see it? No, you are showing me. You are presenting like I'm not seeing the code. Okay, I can see it now. So now I'm asking like, what's the meaning of this mix is equals to my tuple?
So mixed is an array. You can change the name of your mix however you want. Our compiler can infer the type of this particular array because we have given it a value. When we were doing the one for other arrays, we did not give a value to that array. It was just empty. So that's why we had to like give it a type. But for this one, since it already has a value, our compiler can infer that it is an array. Okay, you can change it to any name. This is just an example code. Let's say if I create a new array now and I call it my array. Okay. So it cannot like infer it. You have to define that it is an array. And add whatever value. Okay. You get it right. So now this is an array and this is a tuple. You can put your tuple into your array to like replace whatever value was actually in that array before. Why? Because an array can be expanded. You can add anything you want to it. You can change whatever value you want. But you cannot do that for a tuple because it already has a fixed number that it can receive. A fixed number of values it can receive. Do you have any other question?
No, I'm good. Thank you.
Okay. So does any other person have any question on tuples? Yes, can we hear you, Stephen? Please, let's hear you out. You can unmute and speak. You are muted.
Yeah. Okay. Please, can you go back to the code?
Okay.
The other screen. So you said, let my tuple. Is there must write let my tuple? We can write let.
No, it's not a must. You can come here and change it to whatever value you want. My customer.
Okay. Thank you, ma'am.
Okay. So anything you want. What defines it, like the structure of this tuple, is you have to like give it these parameters, that this is the number of values I want, this is the type of values I want. If I come here now and include another value that is not a number, maybe I put another string, it's going to give an error because my tuple is supposed to accept a string, a boolean, and 2 numbers. But now I'm giving another string. So do you understand? So both the type and the number of items in that particular tuple is defined by this particular line of code, this part. So this part makes it a tuple. and differentiates it from your regular array. So do we understand now? Does any other person have a question? All right. Okay. Okay. So now we're going to move on to another type, another advanced type. Okay, I'm guessing everybody understands that. That's okay. So next we have our enum type. Our enum type is used for fixed set of values. You know, for our type alias, we use this for data you want to pass into maybe an object. Now, if you want to store constants, like different constants, that's when you now use your enums. Okay. So now I'm going to give an example for enums here. Let me so I'm going to do using an enum, we can represent a list of related constants. So let's say if you want to represent a list of t-shirts, maybe sizes of different t-shirts, you don't want to start writing, okay, normally if you want to represent a list of like size of t-shirts, you start doing const small equal to 1, then const medium equal to 2, large. And sometimes you might even want to do small like this. S might be M, this might be L. And maybe if you have extra large, it might be XL, like that, like that. So these are like constants here. So if you want to use an enum to represent a constant, it's like a bit similar to the type constructor, but it's different. Okay. So now let's try to change these constants and put them in an enum. How do we do that? First, we have to define our enum. So let's say our enum, because we want to get a related constant of, let's say this is an enum for different sizes of t-shirts. Okay, it's not fixed. You can change it. You can use your enums for anything, any related constants you need. You can use it for anything. Like by default, the element to your enum starts with 0, but you can also give custom values like I did here for S, M, L, and XL. Okay. So let's say size. Now we're going to write everything here, small. Notice we are using the Pascal case. Everything is starting with a capital letter. Okay. Can write it here. It uses the Pascal case naming convention, right? Okay. So now we have the small, medium. Your values can be anything at all. Okay. To represent your constants. Then we have extra large. You can even have extra large. Any constant you want, you can have it here. You can even have extra large. Okay. So now, in order for us to use this enum, we have to call another variable, size. Okay. Now, this size now is not a type. This size here is an enum because it was defined as an enum. Let's go back to our type. Here, this is a type, and it's giving any because all these ones are commented out. So it does not know the value of whatever is in all those ones, the user and account. Now here we have an enum. They are very different, like very different. Okay. But they have similar syntax. Right. So now we have this. You can call anything in your enum size. You can call your small size. You can call your large size, extra large, anyone. So let's console log this. My size is my size. And you can say maybe let's Emma size be medium. So we're going to console.log Emma size is medium. Let Steven's size be extra large. So Steven's size is extra large. Let's try running this code. So this is like the normal way for you to like do this. But now we're going to use an enum, so we can always reuse these constants. We don't have to always start like calling in one by one. We can just use our enum to locate these our constants. Why are you doing this to me? So I'm going to run this again. Now we can see my size is large here, L, because I called in large. Emma's size is M because it is medium. Steven's size is XL. Okay. So we can even change this our value to small. Maybe if you decide you don't want it to be S again, you change it to small, change this to medium, change this to the inside to large, change this to extra large. Okay. So now we don't even have to come here and start editing. Why? Because we've stored it here in this enum. Any value you want to change, we can change it here and it reflects everywhere in our code. We don't have to change anything here. So let's run it and see if it's run. If it's the value comes up. Can you see? It's no longer L, M. It's now the full name. Large, medium, extra large. Okay. So we can even define our enum as a constant too, because it's like a backpack collecting all your constants. Type is like a backpack collecting all your data. Enum is a backpack collecting all your constants. So you don't have to like start defining all your constants one after the other why you want to use them. Okay. So do we understand the enum? I think it's the simplest one so far. Right. Any questions for enum?
So good evening, Mo.
Yeah.
What's the main difference between this enum now and type?
Okay. So your type now defines the structure or like for your data. Okay. If you want to collect user information or something like that for your database, you use your type to collect it. But if you are using an enum is for constant. It's not something that you can use to like collect information from other people. It's like a constant you want to reuse in your code. Do you get? For example, for our type now, we can have multiple like users here, and each user has a different information, like a different personal unique information to them. But now for this constant, you can be wearing small. Amadi can also be wearing small. Daniela can also be wearing small. So you guys have a similar information among yourself. It's not a unique information like you will store in your type. Do you understand? Without
Yes,
knowledge. Okay.
Yes.
So your enum is for storing constant. So it's not unique to any user or any other person in your application. It is like a global constant. So instead of you to like start defining it for each particular person you want to like give that constant to, use your enum to store the constant. So you just call it, okay, this person is small. You just use that constant, put size dot small like that. And you can change your values any, like you can put any value you want inside of the constant. But the default value for your constant is from 0 to maybe whatever number of values or parameters you have in your enum. Okay, so we all understand this now, right? So your enum is used for storing instance. To promote reusability in your code.
Let me just ask.
Yeah.
It's more of like a clarification, not actually a question. So
okay.
Does that mean like this enum, the purpose I think it is for us to just avoid let me see the code please.
Is so you can talk less
No,
in your code so that you can.
So we will not have to like be repeating the word constant. Like
exactly.
That's what I'm trying to ask.
Yes, exactly. So you don't have to like
so
repeat
the moment you
it.
just declare the enum at the top,
Yes.
any other word wrote after it will
Yes.
automatically be constant, right?
Yes, it automatically become a constant. So it's like storing all your constants in one place. You don't have to start defining constants, this, constant, this. Do you understand? So that's one of TypeScript types that makes our life easier. All right. So I'm guessing everybody understands enum, right? Can I get a reaction so we can move on to the next? Okay. Thank you. So now we have functions. We've been dealing a lot with functions. I'm sure most people will not have any issue with functions, right? So now functions in TypeScript require you to have types for your parameters and types for your return statements. Okay. If you have a function without a type for your parameter, without a type for your return statement, it's going to give you an any type. And we talked about an any type earlier. So that means your function does not, your TypeScript does not know what your function wants to collect, does not know what your function wants to return. So it implicitly gives it an any type. And an any type is very bad for your function. Like let's use a scenario whereby you want to collect information, like a very strict or personal information about somebody, and you're trying to receive it with your function. Maybe it's like an iterative function. I want to receive it with an iterative function. And the person imputes something that is not supposed to impute into that function. There's no way you can know unless you do a unit test to actually make sure that, okay, where they were supposed to put their registration number or where they were supposed to put their email, they did not put a phone number there. You cannot know all those informations except to do a unit test without adding type to your parameters or type to your return statement. So if you have a function and you know if it is multiplying a number or if it is dividing a number, it should return a number, not a string, right? Right? Okay, let's give an example there. So I'm going to do an example for functions to like explain what I'm talking about. All right. Functions. Okay. So let's do a function that can calculate maybe a tax. Calculate tax of our users, everyday person. Tax. Right? Okay. So if we add income and tax. And let's say we're returning income times. So it should return 12% of the person's income here. That would be 1.2. So that's like 12 over 100 give you 1.2. Okay. He's saying tax share is declared for his neighboring. let's remove this parameter first. We can use it in the next function. Now we see here we have a return. We have a return here, but it's giving in any. It's giving us any. Why? Because our parameter is any. Now, if you now come here and say, oh, our parameter should be a number. This the compiler automatically infers this as income, even if we did not put return type income. So if you want to put a type for your return, you have to come here now outside of this bracket, put a column and put your return type. Here, you can see. So each parameter should have a type, and your return type should also have a type. If you have more than one parameter, each of them should have a type, so that your function will not be seen as an any type by the compiler, and thereby cause different kind of bugs in your code. Okay, let's try to so let's so there's one sweet thing about TypeScript here. If you have a large number, you can use your underscore to separate them so you don't get confused. Let's say I want to put 500K. So I can just come in here and put our underscore. And if you want to add more numbers, TypeScript will still see this number as, it will still see it as a number, like this 500 million as a number, even with the underscore. So you'll be able to know that, okay, this number is 500 million. You'll not just be seeing too many numbers put together. That's just one good thing about that state. Yeah. So my tax number, let's calculate that. So console.log tax is this. So this is the parameter for this. You can even come here and put 500,000. It's your choice. Or 5 million. Anyhow you decide to implement your function, you can put your value into a variable, then put your variable in your function, or you can just put the value directly. Depends on how simple it is. Let's try running this and see what it gives us. Okay, so now we can see our taxes. Can you see that it gave us a number without the underscore? So TypeScript is actually seeing this number as a number. That's just a very small trick that we do in TypeScript. It's just small trick. Well, now it's giving us, is this calculation correct? This calculation is not correct. It's giving us how much now? How will I be paying 600 million as tax when I have an income of 500K, 500 million? That's not correct. Right. 12%. 12 over 100 times it. So how come? Let's do 0 please. Let's see. Okay, I think I know the issue now. It's higher. It's not supposed to be higher. Okay. So you know that once we have a parameter, our parameter is number, return type should be a number. Even if this calculation is not correct. Tax is, what's the tax higher?
Excuse me.
Yeah.
I think it's from the calculation. It's meant to be
Yes.
income all over 100 times 12.
Okay. Let's try that. So how much is it now? Oh, 16, sharp mathematician. Thank you. Who was that?
It's me.
Thank you, thank you. Yeah, a sharp mathematician.
You're welcome.
Okay. So yeah, the function works here, but the logic. So our tax now is 6 million out of 500 million. Oops, not true. So let's say we have 500 billion. Well, it's basically the same thing. 5 billion. It should give us the same thing. Okay. So you can see this tax also is also different. So 60 million. Yeah, for 5. Okay. So this is how to like implement a function. This is just a function with one parameter. Do we understand this one with one parameter? I want to confirm if everybody understands the function with one parameter. Reactions, please. Okay. All right. So let's say we want to collect 2 parameters now. So we're collecting both the income and the tax here. Yeah? It's already even very useful. So now we're even already getting an error here because we need to have 2 parameters like it's normal. We need to have 2 parameters. But first, we need to implement what our tax here is going to be doing in our function. So now let's do a logic that if our tax here is 2025, it should return a tax of 1. But if not, it should return a tax of 1.3. So if tax here is less than 2025, if it's not 2025, let it return income /100. So if it is not 2025, it should return a tax of 12%. Else, it should return a tax of, yeah, it should be higher now. If it is higher than yes. 25, it should return 12% of our income. But if it is higher than 2025, it should return 1.4. So now here we can now pass in, let's say 2014. Okay. So now our income is 5 billion and our tax here is 2014. These are the parameters we're passing in. So let's run it and see if it works. Okay. So we can see that it's using Yes. Right. Let's try 2030. With the same and see if it's different. So for 2030, you can see that the tax is higher. So this is how you can do for 2 parameters. So each of your parameters should have its own type. And they should return this. So if you now come here and try to change this 100 now to a string, you get an error right here. Must be type any number bit int or an enum type. You can see. So we can even pass an enum type to our function. Right? So this should return a number, not a string. You cannot return it. Even if you can even try putting a boolean here now, it will also give you an error. Why? Because we have explicitly stated that this should return a number. Let's try implementing this in JavaScript and see if it will actually give us an error. Yes, please. So we're going to try implementing this now. And this is not. Okay, let me remove this one. So now we'll change this to a string and see what it will give us. Can you see? It's returned a Boolean type. Oh, no, no, this is not the function. This is not the function. Why? Run again, John. It did not even return anything. Okay. Oh, I did not console.log. Let's console.log. I did not implement the function. So let's implement the function and see what it gives us. Or this should not be here. Okay. So you can see that it still returned this. It still returned a tax. So you can see that it did not catch this error in our code. It did not know that this was a string and not a number. That tells us that this must be a number, not a string. It is. It gave a longer number. I see. It is not breaking, it's just running. And before you can catch this kind of error, you have to do a unit test to make sure that what is inside here is a number, not any other thing. But right there in TypeScript, where you are actually doing coding, you have to like put the number there. So it helps you to reduce the number of bugs in your code. Very important. Type checking. So do we understand the type functions now? We do, right? Okay. Sharp. So that's just the basic importance for typing in your functions. It makes your code predictable and easy to debug. You easily know where the error is in your code, because why not? You know what your parameter is supposed to be. You know what your return type is supposed to be. So it's easy to catch those small errors. Now, we now have an interface. I spoke about it before. So an interface helps you to define shape or structure of parameters and objects. This helps you to standardize data objects and ensures consistency across your code. Interfaces do not create objects, they define how objects do. Just like the way your type defines your data, the way your data is for your union type or intersection type. Your interface can also do the same thing your type does. Okay, your interface can also do the same thing your type does, but your type cannot do what your interface does. Your interface can extend a class. Interface can be implemented in a class. Now, what is a class? Okay, you can also inherit, an interface can inherit another interface. It can extend itself. Interface can do wonders. Okay, your interface can inherit another interface. Let's say you have a parent interface that has name. You know what we had to do with our type? You know, in our type, we had to create a new type that will now collect the type of the first object and the type of the second object. But for your interface, you don't need to start creating a new type. You just need to extend the former type you have, like the former interface you have, and add more things under. You don't need to like start creating a new type to start adding or using your intersection type to start combining them together. No, that's the beauty of an interface. You can extend it. It can inherit properties from its ancestor, the other interface in front of it. Okay, now also classes. Classes are blueprints for creating objects. It's a core part of object-oriented programming. Programming languages like C#, C++, Java, and C#, C++, and Java, they use the object-oriented programming, where you have classes that can have subclasses, and it just helps you keep your code very modular and structured. And it's very good for building large-scale projects. Okay, it combines data, that is your interfaces or properties, and behavior, your methods and function, and a constructor that initiates its values. So I'm going to explain all these things now with code, the interface, how to explain an interface, your classes, and how to create a subclass and all those. Then we're going to also talk about access modifiers. Okay, so we have your public, private, and protected. Your public modifier can be accessible anywhere. Your class, like if you give a member of your class the public modifier, that particular member can be accessed everywhere. Let's say you're building an application and you want the dashboard to be accessible to everybody. Use the public modifier. Then the private, you want their password to be only accessible to them. Then use your private modifier for that particular member of that class. Your protected modifier can be used inside of a class and any of its subclasses. And a class, you can use when a class wants to implement an interface, you can also use an interface to implement the class. Okay, so now I'm going to start with explaining how an interface works. Let's go to our VS Code and do that sharply. So I'm going to use the example from our type and see if it actually works the same way as an interface. So I'm going to replace that type with an interface. Where is our type function? We started from here. So we're going to implement and change all these types now to interfaces and see if it's going to work the same way as the type. Okay, so now here we have a type. Let's change this to an interface. Now, if you notice the structure of an interface, sorry, not that. There is no equal to here, but in your type, you have an equal to. So if you are writing your interface, there is no equal to here. So now I'm going to come here and remove this equal to. Change this also to an interface. Let's try changing this to this. And it's not working. You have to extend it if you want to use an interface with this. Let's try running this code and see what comes out on it. can you see we also got everything we're supposed to get, even using an interface. So let's go back to that slide. Now we can, let's go back to the interface. I want to check the extent. We can extend an interface. Okay, let's try extending this interface and see. Interface accounts. So now, since we're extending, this account is extending user, we need to add all this into this. Still getting the same thing. So we do not need to initialize this again, this user inside of this account again. It's here. All right. So let's try doing a fresh one now to really explain the interface to avoid any confusion. Here. So now I'm going to create an interface for the company. Yeah. And it's already suggesting it already. That is that I want to do employee now. So it's going to have an ID number, a name, which will be a string, a salary, which will be okay. So now we can even make this our ID read-only. The read-only property makes sure that nobody can come into this our interface and change whatever number is here. If a company is trying to make a database for its employees, it does not want anybody to change the number, the ID number of any employee, because that's the way they can easily get that particular employee. So we can change this property to read-only. Okay. All those access modifiers, you can also use them in interfaces. Your read-only, public, private. But read-only, we're going to use this for our ID. This read-only now is going to make our ID property read-only. So we cannot modify it. And like an external person cannot modify it. So now let's employee, sorry. And now we're going to call our interface class. ID should be 1. Name. Yeah. John. His salary. Now we can also use that I talked about earlier, 500, like this. And TypeScript sees it as a number. Okay. Now let's say I want to now add a manager. But instead of me now to start implementing a new interface and adding ID, name, salary for the manager, I will just extend my employee interface. Okay. Now I'm going to give it departments. Which head of department is he or she? Then, is there another thing I can give a manager that differentiates him from any other person? Maybe his office. His office number. Okay. So now let's implement the object of our manager. So our manager object should have his ID, his name, or her name, Jendo. Okay. Sorry, this is misspelled. Should be manager. With equal to. Okay. So now we have Jane. Okay, let's see. Our intelligence is already even taking our coding convention. So now our manager has an ID of 2, name this, and you can see now that we did not need to implement a new data structure for our manager interface. We don't need to start adding our ID, name, salary. We just need to extend the employee interface, and then we just implement it here. So we don't even need to use the intersection type to start adding or doing anything. Now let's try console logging this information. So now we can console log employee name. So I don't want to use this. I want to use our tilde sign. So I'm going, because I want to put a variable inside of this. Employee name should be our employee objects. Name, like this. Then employee salary. Salary. The employee objects, no, $sign. Employee dot salary. Right? You see that sign? So we can do the same for manager. Tilde sign, manager name. Manager, that's the name. Salary. Manager dot salary. Here, departments. Manager dot departments. Tilde sign, close brackets. Okay. So now we can see. Let me put this down here so it doesn't look English. Okay. So these are interfaces. We have an interface for the employee that has ID, name, and salary. Now, if we extend the manager, we should have the manager to extend the employee interface. It's just, instead of us now creating a new interface and start adding the employee or manager interface together, it already adds it automatically with this extends keyword. It adds both all the data structure of our employee. We add it to data structure we have now for our manager. So if we're now implementing our manager, we just need to take the data from here, ID, add our ID, add our name, add our salary, add our department, add our office, because we added the same. But now we cannot come to employee and put departments. It will give an error. Why? Because this particular data structure was not implemented in our employee interface, because it does not extend the manager. It is the manager that extends the employee interface. Okay, let's try console logging this. So and see the implementation. You can see now we have employee name, salary, manager name. It's wrong spelling, sorry. Okay, department. Sales. Did you have any questions? Anybody with any questions? Do you understand to this point? Let me take a question. Do you have anybody with any question? Do you understand the interface?
Yeah, I think like my only question is that extension. Like
Okay.
you must mention like difference between the interface and the type is that extension, right? So like what's the extension? What's it going to do? Like can't we just go to the for that type, can't we just go there and just write
Listen.
whatever I want to extend here?
Now, it's inheriting the data structure of this employee. So I don't have to come to my manager and start copying this data structure and put in the manager. Normally, if I'm using a type to implement this now, I will have to create a type for the employee, create a type for the manager, then use my intersection type to join them together. That means I have to create a new class to join my employee and manager and just call it manager employee class or something like that. Do you understand? Now for the interface, instead of us to go through all that stress of having to create, there are different scenarios where you will need your type that is more convenient for you to use, and there are different scenarios where you will have to use your interface. So it depends on how large of a scale that project is. Okay. Now the interface helps you to extend the employee because there are sometimes you have like more to this, and instead of you to start typing every other thing one by one or start creating a new type or a new interface to combine them with your intersection type, you just extend it and add more information to your new interface. So you cannot implement the new interface without having to start creating the formal data structure you already have in your code. Do you understand?
Yes, I do. Thank you, Alonso.
Okay. So that's it for interface.
Excuse me.
Yes.
Please, I have a question.
Yes,
Can
I'm
you go
listening.
back to your code?
My code, okay.
Can you go back to your code? Yes. So I wanted to ask the part where the manager extends the employee.
Yeah.
In that interface manager.
Yes.
So what if someone declares a variable like of salary in that manager, and there's already a variable named salary in the employee?
It's a repetition. You see it as
like
a repetition. Let's try it.
Okay.
Are you see?
Okay.
It already gives an error.
Okay.
It's actually a repetition. It's there already. So it's like a waste of your own strength and energy. You can easily just extend this. You can add more to this. Like I explained earlier, you cannot come here now and add another object because you already, let me try adding a new salary to manager and see if you can implement it again. Let's try adding a new salary here. Why can't we implement a new salary? It's an object literally cannot have multiple properties with the same name. So even if you come here and stress yourself and write the implementation in this your manager, it will see it here as a repetition because you've already implemented it already. So do you understand?
Yes, I understand.
So please, I need a reaction so we can move on to classes. I think after classes and subclasses, we should be done with this class. So do we all understand the interface part? No reactions. Oh, such you guys don't understand. Oh, sorry, I'm trying to round up with what we have for today, yeah. So, so I done with the interface, but I've done with the extending of interface. Now, how to create a class. So let's try creating a class now. So this is the syntax for creating a class. You first define the class, define the parameters that should go into your class, a constructor that we initiate when you like call your class. This constructor initiates what will happen in your class when you call the class. And then you have a method that does like some kind of action in your class. Okay, so let's give an example for this code for classes. So quickly. Okay. So now moving on to classes. So now I want to have a class named code. Yeah. So now inside of this class, I need to define my parameters. So my coder should have a name, which would be a string. It should have maybe his favorite music, a string. Maybe his age, and give a space in here. And then his favorite language, maybe language he uses on a daily, something like that. Yeah, we move to it. Or getting an error. Has no initializer. So now your constructor acts as an initializer that initializes these properties here. Okay, so now I'm going to write my constructor. So this is just like the syntax for classes. It's the syntax, like the primary syntax for classes. Now here, I'm going to have my, let's break this into name, string, like repeating yourself again, music. So I'm going to give you a way to bypass this repetition. Right, age, number. Then we have language, string. Now, so we're still getting error. Constructor implementation is missing. So after we write our parameter, we do it here, like bring them out here. We have to implement them in our constructor. And the syntax for that is to use this dot name should be equal to name. So if you want to call this our name outside of our constructor, we use this dot name to call it. So this dot music is equal to music. This dot age is equal to age. This dot lang is equal to lang. Okay. So that's our constructor implementation. So this is basically how you can like do your class. Yeah. So let's try to get let's implement the class. So const Emma is equal to, so new, use your new keyword to initiate a class, like this class now. So the name of the class is coder. Now I'm going to put his name, the props. You have to put the name, the music, which is a string, your age, which is a number, and language, which is a string. So now we're going to put Emma here. He likes Afrobeat. Yeah. Is, let's say, 29. And he uses TypeScript. Okay. So now let's console.log. We can also implement something like a function here. So let's say we use our public keyword to get the language. See, almost 11. So we're going to return this. Let's make it more fun. What's his name? This dot name programs in this dot line. So let's see what our code is going to do. It did not run our public outside here. So we're going to, let's console.log Emma. Now, run again. So it gave us our class, which is Emma, music is Afrobeat, age is 29, language is TypeScript. Then this method here now prints as Emma programs in TypeScript. Here. Okay. So now we can use our access modifiers here in our code. If we use our access modifiers, let's make name. His name should be, let's make his name public. Yeah. So once we use an access modifier here in our constructor, it sees this name as a repetition. See the error code, duplicate identifier name. So once we have a modifier here, we can remove this from our code, and you see we don't have any. So his music can also be public. You can delete this. Then his age, let's make his age private. Okay, you can delete this also. We can now make his language protected. So these are access modifiers or visibility modifiers. Okay, so now we can access our name from even outside of this function. And we can also, but we cannot access the age from outside the function. Let's try. Console.log Emma.name. Then let's do for age. Console.log. You can see we're getting an error. Why? Because age is private and only accessible within the class coder. So this is the class coder. We can come here now and access age. And he is age. You see, it's not giving any error. But here is giving an error because it's private. So your private, any variable with the private modifier can only be accessible inside of the class and not outside of the class. But protected is similar to private. The only difference is for protected, it can be accessible by the subclass of your class, but it cannot be accessible outside of your class. It can be accessible by your class and subclass, but not outside. Private can only be accessible in the class. It cannot be accessible in the subclass. Let's try creating a subclass of coder. So we can create, let's make it here. Class web dev extends coder. Yeah, what's similar to the way interface extends. So we're going to give this its own constructor. And make public computer string. I don't want to add a language. Okay, let's do it in this. So now our computer is public. His name, music, age, and language is gotten from this class, the name, music, age, and language. Can we see? And if you want to implement it, we have to use the method super to implement the one we inherited from our class before now implementing the one for this subclass. So now web dev is a subclass of coder. You understand that part, right? So it extends coder, just like the way our interface can extend itself. So our class can also extend another class, but the only difference is you have to implement this that was already implemented here inside of your constructor, then use the super method to write it out before now implementing the one for the additional one you added. You can even add another. Let's add another one and make it private. What can be private? Let's say is GitHub string. Yeah, so we can now come here now and implement it. This.github. GitHub. So this is just the structure. This is how to make a subclass in TypeScript. So the subclass extends your main class. Okay. Now we can try to check if we can get. So let's create a new method and get GitHub. So we can get the GitHub inside of here, but we cannot access that GitHub outside of it. So I'm going to change this to web dev. Then add, okay. So we added this new is Mac Pro and is GitHub. So let's change it to Emma Dev instead. So now we can now console.log Emma Dev. And then, okay. So now we can see that the language is getting an error because it is only accessible within the class, this class. So this language is inheriting the access modifier it got from the class. That's what is inheriting outside of here. But we can get that here. And he codes in. You can see that it's not giving an error here. So this subclass extends everything. It collects all the, it inherits everything. But outside of here, we cannot use the language because it is protected. It can only be used in the class and its subclass. Even here, we cannot implement, which one is private here? Here, the music is private. Let's try implementing it outside of it. Console.log. Emma the music. String. Oh, it's public actually. I meant age. Emma dev age. Music is public. Now you can see that age is private and it's only accessible within Coda. You can see. Let's try. You can see here now that this age is private and it can only be accessible in the class, but not in the subclass. Here, our language is protected. It is accessible both in the class and in the subclass. You can see that it's not giving an area. This is not giving an area. So we know that our public accessible anywhere. Private only within the class, protected within the class and subclasses. Okay, so those are the difference between our modifiers. You can try consuming them. Oh, I'm getting an error. So let's comment out this page to something. This. Okay, so we need to select. Oh, there's another error. Okay. Why is it saying I'm not finding you not looking? Something is up somewhere. Okay, so I might try debugging this code later. Well, so that's the basics between our classes, our access modifiers, public, private, and protected in classes. Yeah. And then this part. So maybe in the next class, we can just finish that and talk about the other types we couldn't talk about in this class. So do I have any more questions? Yeah. Any more questions? All right. If I don't have any more questions, thank you so much for joining today. So I'll be expecting everyone to finish their exercise. Who's that person laughing? If I catch you, everyone to finish their exercise on their GitHub repo because that's like the basic part. Okay. Now this is like more advanced. So that's why I took my time to like take the all concepts, even though we could not finish everything, just remain one part, but that one unless you get. So I've taking my time to explain everything. So if I'm sending my next exercise, I'm expecting everybody to like do the exercise because that's what is going to like be graded in your weekly assignment. So you have to submit a link to your GitHub repo that you for the first assignment, the first exercise, and the second one I'm going to drop tomorrow. Okay, so good night.
Sorry, please. Sorry, please. The assignment, please, can you drop the GitHub again?
On this chat,
You drop everything on your WhatsApp, Joe.
I dropped it on WhatsApp and some people said they did not see it.
Drop it again this night, please, or tomorrow morning, please. Thank you.
Okay, I'm dropping it now this night.
Thank you very much.
Okay, and tomorrow I'm going to drop another one tomorrow. And I don't want to hear any excuse. It's part of it's going to be graded. Okay. So I hope everybody understood today's class. Right.
I will bet that everyone stop at
Sorry,
maybe
sorry,
from
please,
9:30.
I just opened. Hold on, sorry, please. I just opened the GitHub, but I'm still not confused. Like, why am I opening here?
Okay. Read the README file or take a YouTube tutorial on how to fork a GitHub repo, create your own copy, then create your own branch of that repo. After creating your branch, you implement the solutions to the JavaScript code. You change the JavaScript code to TypeScript according to the instruction. Then push it to your branch. After you push it to your branch, create a PR request. That's a pull request to the main repository, so I can merge it to the main repository. Do you understand? If you don't understand, check
Yeah.
YouTube.
No, we don't understand that
Yeah,
one.
but that's the assignment that you
Check
said.
YouTube.
That's the basic part, the easy part.
Check YouTube. The instructions are there already, so you just need to like make sure you get. Yeah.
Okay, yeah, thank you.
Benzumaki. I like your nickname.
Yeah, thanks. Please, where's your ex handle? I want to personally follow you, please.
They're formal on all social handles.
That's all right.
Yes, yes.
Thank you very much.
Okay. Yeah. Thank you for joining. Good night, everybody.
Wow, no one come out. Hmm? Because they never log group guy. Let's say like no in the class.